Hi everyone, in this video I'm going to try and explain the concept of improper integrals at AS level. So we have a question here which is saying the function f is defined by f of x being equal to 4x plus 2 to the power minus 2 for x being greater than minus 1 over 2, right? Then part A is saying find the integral of f of x with infinity and 1 as our limits, right, with respect to x. And that's our question. So we're just going to go ahead and work this out. So if we have integral of 4x plus 2 to the power minus 2, we know we add 1 to the power, integrating that, so it will be 4x plus 2, adding 1 to minus 2, get minus 1. Then we divide by the new power and multiply that by the derivative of the bracket, right? So if we differentiate stuff that's in the bracket, we get 4, right? That's the derivative of the bracket, so multiply by 4. And this comes down to be 4x plus 2, 4x plus 2 to the power minus 1 over minus 4, like this. And we're going to be using infinity and 1 as our limits. So I know you're used to having a number here, but please note that infinity is not a number, and it represents an idea that something goes forever, right? So it's not a number. So we can go ahead and substitute infinity here, right, as a number. No, it just represents an idea, right? So if we substitute infinity, we're substituting an idea that it goes forever, right? And if we do that, this whole thing approaches 0, right? So substituting infinity, the whole thing approaches 0. We're not saying 0 is standing in for infinity, but rather substituting infinity into this expression makes the whole thing approach 0, right? Please get that right, because if we substitute 0 for infinity, we'll get a value, right, which is not correct. So substituting infinity, we will make this approach 0, right? So we'll write 0 as a result, right? Then we subtract, and substituting 1 in there, substituting 1, that's our 4 plus 2 to the power minus 1 over minus 4, right? And we get minus 1 over 24, right? And so 0 minus minus will give us 1 over 24, right? And this is basically how we deal with improper integrals at AS level. It's nothing complicated, but just have to understand that infinity is not a number, and therefore we cannot substitute it into the expression as a number, and we cannot have 0 standing in for infinity, but rather when we substitute infinity, or when you plug infinity in, the whole expression approaches 0, right? I hope I've made that clear enough.